Hello viewers. So we have this question under gases. It says an open tube manometer is attached to a flask of neon gas. The mercury level on the side attached to the flask is 142.6 millimeters higher than on the side open to the atmosphere. If atmospheric pressure is 758 torrs, what is the absolute pressure of the neon gas in the flask expressed in atm? So to solve this question, we need to understand that we have two types of manometers. We have what we call the open tube manometers and we have the closed tube manometers. So we have the open tube manometer. Let's say open tube manometer. Let me represent them by letters. We are saying this is O for open, T for tube, and M for manometer. Then we have the closed tube manometers. So we'll say C, T, M on the other side. So we need to understand the difference between these two. So an open tube manometer is a manometer that has got a side that is open to the atmosphere. So what we mean is this. We have a manometer that looks like this. Let's say we have this diagram here. This is a manometer I'm drawing for you. Let's put it like that. All right, so we have a side that has got a gas or that is containing the gas. Let's say this is the side of the gas, and then this is the side of the atmosphere. So we have atmosphere there. Yes. Then we have another one on the other side where we are saying we have our manometer like this. The same diagram again. It may look different a bit with that one in my drawing because maybe it's not accurate like that, but I hope you understand. Now, where we still have the gas in here, this is the gas, and then we have the atmosphere there. All right. So what we mean by closed tube manometer, we mean that there's no side that is open to the atmosphere. You can see this side of the gas is closed and also that side is also closed. So there's no atmospheric pressure that is affecting the liquid in this manometer here. It can be the liquid or the gas, but it's not affecting the liquid or the components of this manometer inside here. Remember, a manometer is used to measure gas pressure as well as liquid pressure. So the atmosphere in this case for a closed tube manometer is not affecting anything inside there because the tube is closed away from the atmosphere. But for an open tube manometer, as you can see here, we have the side of the gas, but we have a side that is open to the atmosphere on the other side there. So we have a side that is open to the atmosphere. That's why we are calling it an open tube manometer like that. So now, we have two types of open tube manometer. So we have two forms or two situations. Let's call them two situations. We can have this situation we have here. I will indicate that to you soon. Let me just have another drawing. All right. So we still have the same thing. We have gas here. And then we have the atmosphere on the other side there. Still the same thing. The atmosphere there. So now we have a liquid that we use inside the manometer here. Mostly we use mercury. So let's say we have this situation where we have a liquid of mercury that is filled like that up to that state there. And then we have another one here that is in this format. All right. So we can see both of these are open tube manometers. This side is open to the atmosphere. That side is also open to the atmosphere. So they are both open tube manometers. But then the difference here is you can see the mercury level here is higher on the side where the gas is present. And then in this case here, the mercury level is higher on the side of the atmosphere. This is the difference between these two manometers. They are both open tube manometers, but the liquid in this case is higher on the side of the gas, and the liquid in this case is higher on the side of the atmosphere. This happens when it's higher on the side of the atmosphere because the pressure of a gas here, the gas pressure in the container here in the manometer is higher than the pressure of the atmosphere. And in this case, it's higher on the side of the gas because the atmospheric pressure here is higher than the pressure of the gas. That's why it's pushing like that. So these are the two situations we have for open tube manometers. So we have one where the mercury is higher on the side of the atmosphere, and we have one where the mercury is higher on the side of the gas. So let's look at the closed tube manometer and see what happens there. So even here we can have a situation like that. Let's say we have a situation like that. But for these ones now, for closed tube manometers, you find that in this case, the pressure of the gas and the pressure of, remember the pressure of the atmosphere here is zero because it's close to the atmosphere. So we only have two pressures here. We have pressure of the gas, and then here we have the weight of the gas. So we'll look at this one first. Let's look at these two here. Let's see the formulas we need to solve questions that involve this type of manometers or situations. So for the first one, all you have to do is look at the information you have. Remember, on this side of the gas here, the side of the gas, we have gas pressure. Then the side of the atmosphere, we have atmospheric pressure. But remember, the side that is higher, okay, the side that is higher has got also a pressure. We'll call that pressure the weight pressure of the liquid. You see that this side where the liquid is higher, you find that this liquid is exerting a weight pressure on this container here. So we have a weight pressure there, and then we also have atmospheric pressure. Here we have gas pressure. And then in this case, you find that we have gas pressure here, then we have the weight because the mercury is higher on this side and is lower on that side. So the weight will be on this side here. So let's see the formulas we can use. The formulas we can use here are, for the first one, for this one here, we are going to say on this side, we only have pressure of gas. So we'll say we have P gas, pressure of gas, and this must be equal to, we're equating the pressures. So we are dividing this in two sides. We have the side of the gas, and then we have the side that is facing to the atmosphere there, or the other side of the container. So we have the side of the gas and the other side of the container. So we're equating those two sides. So on the side of the gas here, we only have pressure of the gas. So we'll say P of gas is equal to, on this other side, we have pressure of the atmosphere, and then we have the weight of the liquid. So we'll say this is equal to pressure of the atmosphere. Let's use ATM for atmosphere. And then added to, because we have two pressures there, the weight, the pressure of the weight, we call it just the height of the liquid. So this is the formula you need if you have this type of situation where the liquid is higher on the side of the atmosphere. What about this one? So this one, you see that on this side of the gas here, we have pressure of the gas, and we also have the height or the weight of the liquid. So it means here you have those two, and on the other side you only have the pressure of the atmosphere. So our formula here will be pressure of gas added to the height. Since the height is on the side of the gas, this must be equal to pressure of the atmosphere, like that. So that's the formula we need if we have this type of manometer or situation. And if we have this type of situation, we are going to use this formula. So these are the two formulas we need for open tube manometers. Yes. What about the closed tube manometer? For a closed tube manometer, the pressure of the gas is just equal to the height. So the pressure of the gas is equal to the height of the liquid in that case. So when you are given a closed tube manometer, for a closed tube manometer, the pressure of gas is equal to the height. As long as you are given the height, that is the pressure of the gas. Height of the mercury or the liquid you are using is equal to the pressure of the gas. So these are the three formulas we need. Given situations, if we are given a closed tube manometer, we'll need this formula where we're saying pressure of gas is equal to height of liquid. And then in this case, if the height is higher on the side of the gas, you basically need this formula where we're saying pressure of gas added to height is equal to pressure of the atmosphere. And on this other side, you say pressure of gas is equal to pressure of the atmosphere added to the height, given the situation. All right, so let's look at what we have here in our question. The question is saying an open tube manometer is attached to the flask of neon gas. The mercury level on the side attached to the flask is 142.6 millimeters higher. So they are saying the mercury level on the side attached to the flask. So the side attached to the flask, is this side here, is higher, 142.6 millimeters higher than on the side open to the atmosphere. So we are told to say it's higher here than on the side open to the atmosphere. So in short, the type of manometer we're looking at here is not this type. This type we can see is higher on the side of the atmosphere, but what we are looking for here is where is higher on the side of the gas. So we are using this type of manometer here. And then the formula we need is this formula here, where pressure of gas added to height is equal to pressure of the atmosphere. But in this case, we are looking for the pressure of gas. So making pressure of gas, the subject will say pressure of gas is equal to pressure of the atmosphere minus the height. So let me get rid of this other part here. So we are saying the formula we're going to use is pressure of gas, like that, added to the height is equal to pressure of the atmosphere, like that. Making pressure of gas the subject, will say pressure of gas is equal to pressure of the atmosphere minus the height. Then replacing with what we have, we are given to say pressure of the atmosphere is 758 torrs. Then this will be subtracted by the height is 142.6. So it's 142.6 millimeters higher. So we use millimeters of mercury. In short, the liquid used is mercury. So millimeters of mercury is also a unit of pressure. So 1 millimeter of mercury, like this, is equal to 1 torr. So the pressure you have in millimeters of mercury is the same pressure you're going to have in torrs, and the pressure you have in torrs is the same pressure you're going to have in millimeters of mercury. So it implies to say we can put our units here as torrs instead. Remember, we can't do mathematics using different units, so the units need to match. But here, we don't need to convert anything because 1 millimeter of mercury is equal to 1 torr. So we'll just say we have 142.6 torrs, and that matches with the unit we are given earlier on. Doing our mathematics there, what we are having is we'll have 758 minus 142.6. We are having a pressure of 615.4 torrs. So this is the pressure we have in torrs. So this is the pressure of gas in torrs. But then we are told to say we need to express it in the units of atm. All right, so let's do that. It implies to say we need to now convert the pressure we have from torrs to atm, and that will be now our final answer. So let's look at that and see how we can convert our pressure. The conversion we need is 1 ATM is equal to 760 Torrs. So this is the conversion factor that we need. 1 ATM is equal to 760 Torrs. So we'll say to convert now, we have 615.4 Torrs multiplied by, we are going to say 1 ATM. Since we want to get rid of the unit of Torrs, we are putting it down there, is equal to 760 Torrs. So the unit Torr and Torr will go, this and that will go. It implies to say now our answer will have the units of ATM. So the answer I'm getting when I do that is 0.81 ATM rounded off to 2 decimal places. So this is the answer we are looking for in this question. 0.81 ATM is the answer that we are finding. So that's how you go about questions that fall under manometers.